find the inverse. Okay, we're going to go through the usual method here, although there might be others you can try to use. First of all, here's the statement. And if you immediately switch x with y, you have the inverse. However, you want to solve it for y, so we'll use the alternate form. It looks like this. 4 to the x is 3y minus 2, and then we'll solve that for the y. So let's see, 3y would be 4 to the x plus 2. So it's going to be 4 to the x plus 2 over 3. So there's your function. That is the inverse. So if that was f of x, then what we have now is f inverse. Okay, now let's take a look at the domain and the range. Now, this was a log function here, and we know that this domain for this original function must be all x such that that quantity is positive. So 3x greater than 2, x greater than 2/3. Okay, now that's what we expect the range to be for this function, our inverse. Its range should be the same as that. So we would say y is greater than 2/3. Okay, and that's pretty clear from this form of this, that you have the 2/3 plus this number 4 to the x over 3. And so this is at least 2/3, whatever happens here with this 4 to the x over 3. It could never be smaller than a 2/3. Okay, never be 2/3 or smaller. So that makes sense. Okay, now also notice, if you look at this inverse function, x could be anything. I mean, that's pretty clear that the exponential function has all real numbers for its domain. So our domain is x real. And notice that back here in this function here, this log function, this is a typical log function, and its range would be -∞ to infinity. Notice that's the domain of our inverse function. And of course, you can graph these. Okay, now here is the TI in action. And I've got the natural log function here, the log function. And you have to use this conversion. And in other words, use the definition for the log with a base 4 by using that conversion. And then you'll use that to get the graph. Otherwise, I mean, we don't have a log base 4 function on the calculator, so you have to use this. So I have them both in here, the inverse and the function itself, and then just do a graph. And notice you do see that telltale symmetry over the y equals x axis. So all complete